Hey everyone, in today's video, I want to go over some of the new features of Python 3.11 that I found interesting. It's available now. It was released a couple of days ago at the time of recording this video, so you'll be able to do everything that I'm showing in this video today. The first feature has to do with improved tracebacks. So here I have some code. It basically just assigns the letters A to J to the numbers 1 through 10, and then it divides all of these here just like you see, and it prints out the result. So let me go ahead and run this just so you can see what it looks like. And it gives me a really small number. Now, if I were to change this to have a zero somewhere, let's say 5, and I change that to 0, and I run this using Python 3.10, we see I get this error message, right? So it's telling me that there's a zero division error somewhere in this expression I'm dividing by 0, but it's not clear where. Now with Python 3.11, if I run this, so Python 3.11 is my default now. So I still see the zero division error, but it's giving me more precise information on where the error is occurring. And we see it's happening after the D and before the E, so the division there. So I'm trying to divide by 0 there. So it's saying that E is 0. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Yes. So E is 0, and that's the part that's failing. If I change this back to 5, and I change, let's say, the 9 to 0, which means the I in this case will be 0, and run it again, we see now this little arrow is pointing to the division sign right before the I, which means the I itself is 0. This is going to save you time when you're debugging because it's going to show you exactly where something is occurring. So you won't have to kind of look at everything in the area. You'll have a better idea of where to start your investigation when you're debugging. So I think this is a great addition to Python 3.11. The next thing I want to talk about are different ways of creating groups of asynchronous tasks. So right now I have this example of the old way of doing it, or the standard way of doing it. Here I have this async function which will basically print start and end and return finish along with some number that I pass in, and it's just going to sleep for however many seconds I pass in. So I want to run this multiple times in a group. So the typical way you do this is with gather. So you create a list of tasks. So I have this task list, and I just create a bunch of tasks from 1 to 5, well, really 1 to 4. And they're calling this async function that I've defined up there. And then I'm adding them to this task list. So I have the list of tasks. And then I await this list of tasks by using gather. So then gather will run all these tasks at the same time, and it will wait for them all to finish. And when it finishes, then it returns the results from the entire group of them. So this is fine. I've used this before. Of course, you can change this, use a list comprehension, but the idea is the same. You just basically create a list of tasks, and then you await those tasks using gather. So now there's a new way of doing it, and I'm going to copy this one, and I'm going to modify it to support the new approach. So I'm going to call this run with groups. So let's change this to groups. I can get rid of the tasks here because I no longer need a tasks list. And what I want to do instead is I want to use async with, and I want to call the class called task group inside of async IO. So async with async IO, and then I can assign this to a variable. So let's call this TG for task group. And then with this task group, whenever I add a task to this group, it will immediately start running. And this async with block won't return until all the tasks in the group have finished running. So let me go ahead and indent this. Let me show you how it works. So the loop here, looping over 1 to 4, still appears. But instead of creating a task like this, what I can do is I can say tg.create task. And then the rest of the API is similar. So instead of using the standard create task from async IO, I'm using the one from task group. And then I'm creating a task. And then I don't need to append it. I don't need to append it to a list here if I'm not interested in the results. And then I also don't need to run async gather anymore because, like I said, these will start executing right away. So let me go ahead and run this. So task groups. So right now this is going to use the gather, and we see it starts them all at the same time. and then they slowly appear for the other ones because the first one takes 1 second and the last one takes 4 seconds, right? So now if I do this with group, so groups, just like that, and I run it, we see it works just the same. It starts them at the same time and it returns. And I see I have this print results here because I didn't remove it. But let me go ahead and just run that again. We see start 1, 2, 3, 4, and then in 1, 2, 3, 4, and then it's done. But I don't have the results for this. So this is a little bit of a limitation. It depends on if you want the results from your tasks being run. Oftentimes you don't. You just want to make sure that they run and don't fail. But if you do want the results, here's what you can do. So you can do results equals an empty list, and then you can append each task to the results. So results append task. And then outside, I can print the results. So print, and then I'll use a list comprehension for this. So task.results, or actually results, singular, for task in results. And you can call this tasks as well. And now if I run this, I see it still works the same, but at the end, I get the results from this. So if you want the results, I think async io.gather is a little bit more clear on how it works. But if you don't care about the results, then task group is definitely a lot better. The last thing I want to talk about are exception groups and exception notes. So before I get into that, let me just show you this function that I have. Here I have this function called load URLs, and I have a list of 4 URLs. Out of the 4, only 1 is valid. What I'm going to do is I'm going to loop over these 4 URLs, and then I'm going to try to send a GET request to them. But because only 1 is valid, only 1 should work. But because I have an exception here, it's going to fail on the first one because the first URL is invalid. So let me just go ahead and run this exception groups. And we see I immediately get an error. So what I can do is I can use a new feature called exception groups. And exception groups allow you to pass multiple exceptions at the same time. So this is useful in cases in like async programming where you can have many things running and many things can fail for different reasons. You can group all those exceptions together and deal with them as a group. So this example that I'm showing isn't very realistic, but I think it's clear to show you how exception groups work. And the way that I'm going to do this is first, I'm going to create a list that will hold a bunch of exceptions. So exceptions equals an empty list. And what I'm going to do here is inside of the exception block here, instead of raising, I'm going to append the exceptions to this exceptions list. So exceptions.append E. And now when I run this, we see it runs, but all the exceptions were suppressed because I appended them to this list. So now that I have a list of exceptions, the way I can raise the entire group is by using exception groups. So to do that, outside of the loop here, what I want to do is I want to raise exception group, just like that. You can give it a name. So I can say request errors is the name. And then you have to give it a list of exceptions. So just save that and I'll run it again. And now the results have multiple exceptions. And if I go to the top, we see exception group traceback. And then it just gives you information about the entire group. So raise exception group, request errors, and then we see 3 sub exceptions because 3 out of the 4 URLs are invalid. So now how do you handle this in the exception blocks? The way you do this is first, let me put a try here, is instead of using except, you're going to use except star. And the way that except star is different from except is multiple except stars can run in one try except block group. So typically when you have try except, when it hits the first except that applies, only that one will run and the whole block exits after that. But now with except star, multiple except stars can run. So let me go ahead and bring in the exceptions that could happen here. So we have request.exceptions invalid schema is 1. And what it does is it catches the entire group. So it's going to create like a subgroup for you, and it's going to group all of the invalid schemas into a sub exception group. So that's why I'm calling it EG for exception group. and I just want to print, let's say print invalid schema. And then I'll do the same thing for the other two. So one is going to be missing schema, and I just put missing schema here. And then the last one's going to be connection error. So connection error, and then we can say connection error here. So now when I run this, let's see what happens. We see invalid schema, missing schema, and connection error. So those print statements all ran even though it matched multiple of them. If I only had except without the star, then it would have stopped on the first one and then the other two wouldn't appear. You wouldn't see them. So now let me just show you the last thing that I wanted to talk about, which are exception notes, which are pretty simple. So inside of exception, you have the ability to add a note to each exception that you're dealing with. So here E now has this method called add note, so any exception. And what you can do is you can add extra information onto the exception. So typically what you would do is you would like create your own exceptions that support additional information. But now you don't have to do that. You can just use e.add note and you can add any extra information you want. So what I'll do is I'll add the URL here for the note. And inside of the print statement here, what I'll do is I'll print out the note information. And I'm going to use a list comprehension here because this is an exception group and I can have multiple exceptions. In this example, I only have one per group, but I could have multiple exceptions per group. So I'm going to loop over them. So for eneg dot exceptions. So each exception in the exception group. And then here I want to take E and then dunder notes, and I just want the first note, right? So it puts all the notes here in this dunder notes, and because I only have one note per exception, I'm just getting the first one here. And I can just copy this and paste it to the other ones, and I can run it. And now we see for the invalid schema, we have HTTPSS, which is invalid schema, a missing schema. So there's just nothing there for prettyprinter.com. And then connection error, when I do prettyprinter.coms with an S on the end, it can't connect there. And then for the other one that is correct, nothing happens because there's no exception there. So like I said, this isn't really a realistic example, but I do think it shows the case where you can have multiple exceptions in one thing, and then you can handle all of those exceptions at the same time. So there are some other features in Python 3.11 that I didn't cover. Like a big one has to do with speed improvements. I couldn't think of a good way to demonstrate that because most of the code that I write is limited by input and output, not necessarily like the speed of the code execution. So the speed changes probably won't affect me, but it is something that's going to globally affect all Python scripts. So you don't have to do anything different to benefit from the performance increases. You just write your code as normal, use Python 3.11, and there's going to be some speed increase. You don't have to switch to something like PyPy to get an increase. Like you just use it like you are right now, and you're going to benefit from increased performance. And there are also a bunch of other things added to the typing module to make writing type hints a lot easier. There are a few of them. I didn't want to cover them in this video, but if you're using type hints in Python, then you'll probably benefit from the new type hints and features around type hints that were added in Python 3.11. So check out the link in the description below. It's going to talk about like the different changes to Python 3.11. And in the comments below, let me know which features you like, which features you don't like. Do you think these are good additions to Python? Do you think they're not really necessary? Let me know in the comments. So that's it for this video. Feel free to give me a like if you like this video. And if you haven't subscribed to my channel already, please subscribe. So thank you for watching, and I will talk to you next time.